Hello everyone, my name is Maria Villalpando. I'm a researcher at the Dominican Foundation for Marine Studies, FUNDEMAR for short, and I will be presenting to you today, Margaret already said the title of the presentation, to assess any differences in settlement and recruit survival on Acropora palmata recruits using different substrate types and different culturing methods. I also want to acknowledge my co-authors, the people who made this work possible, and that it was also done in collaboration with SECOR International and the Nature Conservancy. So as good scientists, we usually, to make good science, we start first defining our question first, and then designing our methods to answer those questions, right? But FUNDEMAR is an NGO that works in active implementation of restoration techniques, and sometimes questions emerge from the program itself that we want to answer, because if you are in an NGO, you know that one year you'll have certain types of substrates and then the next you don't, and then one year you can put an in-situ pool, but then the next you don't because there's a hurricane coming. So we work with what we have, and from this general program, we have whatever we have to do, and then we decide, okay, this is the questions that we have that we want to answer. So in this case, I will be presenting our spawning event for Acropora palmata in 2020. First, the general program. So we are located here in southeastern Dominican Republic. It's beautiful. If you want to go, we have great islands and people and music. And we're based here in Villalpando. Villalpando has strong roots in artisanal fishing, and now has become a tourism hotspot with over 1 million visitors per year. And our mission here is to conserve coastal marine ecosystems and resources. We do this through two main programs. One is a marine mammal protection program. The other one is a coral reef restoration program, which I will be focusing on today. And in the case of Acropora palmata, close to the hotels, they installed reef balls 10 years ago, and now they harbor a really healthy population of Acropora palmata, where we can collect gametes every year. And in August 2020, 4 days after full moon and 2 hours after sunset, we collected gametes from 10 different parent colonies from palmata, and we achieved an 84% fertilization rate. And after this, we culture them in our ex situ lab, where we have 12 aquariums where we can grow, culture, settle the larvae before putting them back to the reef. And we also have SECOR cribs, or coral rearing in situ basins, where we can put a high volume of substrates and have a little bit less maintenance involved in the culturing process. And for the cribs, the substrates are already there, but in the case of the lab, when the larvae start swimming down the water column, we provide them with different substrates so they can start settling. So here we have the two substrates that were designed and created by SECOR International, the ceramic gear substrate and the cement tetrapod substrate. They are designed specifically to be seated directly onto the reef without need of any glue or nail or zip ties. They really facilitate the seating process. And there's still a lot of work to be done to understand what the difference are for the short and long-term survival of coral recruits on the substrates. But the general knowledge of it is that ceramic might help in reducing the growth of harmful macroalgae, and therefore might help the long-term survival of recruits compared to cement. So this year we were able to give our babies these substrates, and they start looking for a place to settle. And when they're fully metamorphosed, these little baby polyps, we take them to a reef site called the sombrero site, because it looks kind of like a sombrero. And there in Sombrero, it's a shallow reef site, 2 to 3 meters. It's a reef crest impacted by waves, but palmata used to grow there like crazy, and now it's a degraded site with a lot of palmata skeletons. So here we have an intervention site, which is where we do all of the coral seeding and mini fragments of palmata as well. Next to it, we have a control site, and we also have a reference site so that we can be able to assess the change in benthic cover and fish communities through time and see if the intervention site starts to look more like the reference site or just keeps looking like the control site. So on the intervention site, we seed all our little babies, and from this fertilization and seeding event, we wanted to know if there are any differences in the settlement, in the number of recruits, and the survival after 1 year between the in situ and ex situ culturing methods, so the lab and the cribs, and between the ceramic gear and the cement tetrapod substrates. And if so, if there are differences, what would be the best option to assist the sexual propagation of palmata? So we assessed the settlement and survival in 64 substrates of each treatment. 64 because we did an a priori analysis, and with this amount of substrates, we would have enough power to do statistical inferences. So we had 64 ex situ, so lab gear substrates. We had 64 in situ, so crib gear substrates, and 64 crib tetrapod substrates. And the ceramic and the tetrapods were cultured in the same pool. We did a block design where the 3 levels of treatment were repeated. So we had a monitoring transect, and on each meter squared, we had each of the 3 substrate types. And then for the analysis, we did blocks to have like 4 replicates of each inside one plot, inside a 4 meter squared plot. In the end, we had 16 plots that we used for the analysis. We counted all the settlers and took individually, seated them on the reef on their little spots, and we monitored each recruit after 3 months, after 6 months, and also after 1 year, which is what we are going to be looking at today. And these are other cute pictures of little baby palmatas after 1 year. So in order to be able to compare the substrates, since they have different surface areas, we standardize those areas by recruits per centimeter squared for the analysis. We did a permutation analysis of variance based on nuclear distances for the settlement, for the number of recruits after 1 year, and the survival percentage. And we also tested the homogeneity of dispersion in each of these cases. So first, I'm gonna give like the macro results of their performance. So we started with 64 substrates, and we ended up at least with 60. So they all had a similar retention, which is very good, which is very high, higher than 93%. And from the 61 substrates that we had after 1 year, at least 29 of them had 1 recruit. Some of them could have more than 1, but at least 1 recruit on 29 or 30 of them. So they also had a similar yield after 1 year, the 3 of the substrates. So in this more macro sense, they performed very similarly, if not the same. So what happens when we see it at the level of the recruit? In terms of settlement, I put it in total settlers here, so it's easier to understand than in settlers per centimeter square. But you can see that we had very high settlement. For the in situ, we had an average 50 settlers, and for the ex situ culturing system, we had on average around 100, so double the amount. And it's probably because in the laboratory, you have less volume of water, more density of embryos, right? But there were no significant differences, even though it was 2 times higher in this case. But for the substrate types, there was a significant difference found, where the cement tetrapods had 2.6 times more settlers than the ceramic gear. And they were at the same pool with the same density of embryos. Ooh, 3 minutes, okay. So the recruits after 1 year, after 1 year, you see like now we don't have 200 little babies there. Now we have max 10 or so. So mortality is huge at this life stage. But you can see that the ex situ and in situ now look the same. And even ex situ had a little bit less total number of recruits, but there were no significant differences, as well as in the ceramic gear and cement tetrapods. So when we assess survival, then we start to see differences again. Why? Because the ex situ system started with a lot of settlement and ended up with the same amount of recruits after 1 year. So there was a high mortality in the more dense substrates, the ones that had more recruits to start with. And we see the same pattern between the substrate types. So the cement tetrapod started with really high settlement and ended up having the same number of recruits as the ceramic gear. So there was a lot of mortality in the cement tetrapods, but they still performed the same in terms of number of recruits. So the difference in survival was clear in these cases. So in conclusion, the cement tetrapods had higher settlement, but also the highest mortality. The ceramic gear had lower settlement, but higher survival after 1 year. And there were no differences in culturing systems during settlement, but the in situ culture system had higher survival. And this could be because of density dependence mechanisms. It could be because of intraspecific competition, predation, amongst others, that make this mortality seem even larger than what it is, right? So this is valuable data for us to make decisions on recruit propagation on Acropora palmata, but we still need more information to make the best decisions for our local programs, such as cost-benefit analysis, what is more cost-effective for us to produce in terms of the substrates or in terms also of the culturing methods, and also assess what happens after 5 to 10 years with these recruits, right? Because we only have 1 year of data for this. So lastly, I just want to thank all our partners, the people that make this possible, our sponsors, and of course the team in Villalpando that are very committed, put all their hard work to make this happen. Thank you very much.
Thank you so much, Maria. That was, I'm also really proud of these results. The Dominican Republic team is amazing at FUNDEMAR. So any questions that we have for Maria? One or two. Jenny?
Just a quick question. When you're looking at the total number of recruits, is that per substrate? So you have like 100 on one substrate?
The settlers?